Hey everyone, we're going to start working on quadrilaterals today. I'll get the test graded as soon as I can. So we get the grades hopefully back. We'll definitely get them back before Christmas. What I'm hoping for is you guys on Friday, next Friday, or this Friday coming up, that I have the test back for you so you can see those before you get back for Christmas. I get them back to you. So quadrilaterals, we're going to kind of run through this quickly. We'll get through it. We'll do an online test next Wednesday. You'll have nothing to do over Christmas break, and then we'll come back and kind of rush through and dig deep. We're going to rush through, but we're definitely going to try to dig deep into what we need to know through January to get through the course. So quadrilaterals. One thing we know about quadrilaterals is the internal angles of all the quadrilaterals have to add up to a certain measurement. So when we talked about triangles, we knew that the angles inside a triangle all had to equal, when we added them together, they had to equal 180 degrees. We know squares, the internal angles of a square all add up to 360. We work from there, and we kind of go through them all, and this is our equation that we can use to figure out what they add up to, no matter what size of a polygon they tell us. So we kind of use it quickly. We know triangles are 3, so n is the number of sides our polygon has. Well, a triangle has 3 sides, so if we quickly plug 3 in for n, we get 3 times 2 times 180 tells us that triangles have 180 degree angles. The measurements of the angles all add up to 180 degrees. So we can build on that for any size shape they tell us. Here on an example, we have a 13-sided figure. We want to know what the sum of the measures of the interior angles are. So we're just going to plug 13 into our equation. 13 minus 2 times 180 equals 11 times 180, which is going to equal 1980 degrees. So a 13-sided polygon, I'm not going to draw one, but a 13-sided polygon, all the interior angles are going to sum up to 1980 degrees. What we can then do to find out what each individual angle is we divide 1980 by 13. That's going to tell us that each angle inside the polygon, it's going to be about 152 degrees. The way that works out. It's not perfectly round number, but it's going to work out to 152 degrees for each interior angle. When you kind of do that, it works out to decimal. It's like 0.3, but no big deal. I can put the 0.3 in. So 152.3 degrees is what each individual angle measures, but they sum up to 1980. So our next example is they're telling us that the interior angle, so each individual angle measures 120 degrees. They want to know the number of sides. So kind of what I just did on this last equation is I divided the 1900 by 13 to get the area of each individual angle. I'm going to do the same thing here. To figure out how many sides I have, I need to do 120 degrees, the measurement of each angle, times the number of sides. And I know that that's going to equal n minus 2 times 180. So now we're just into a basic algebra problem. We're doing our distributive property. I end up with 120n equals 180n minus 360. I subtract 180n from both sides. Sorry about that. So subtract 180n from both sides. And I end up with negative 60n equals negative 360 degrees. When I divide by negative 60, I find out that n equals 6. So now I know a 6-sided polygon, the interior angles measure 120 degrees. So if I quickly kind of plug that into my equation for n, I get 6 minus 2 times 180 is going to equal, sorry, make that times, not plus. This should be times 180 is 4 times 180, which is 720 degrees. So it works out. Hope that made sense. There was a little kind of messy writing on the bottom there. But just know that if they tell you the inside angle, then you multiply that by n, set all that equal to n minus 2 times the 180, you can figure out what the number of sides of the polygon is. The next page, on the page that you have some questions, kind of go through them, figure out what the interior angles sum to. We're just looking for the sum on these first 6. Enter your answers in the Edpuzzle, and then we'll move on. Okay, so a decagon. A decagon. If you're not quite sure what a decagon is, I hope you looked it up. But that's a 10-sided figure. So 10 minus 2 times 180 is 8 times 180, which that works out to. That's not right. 8 times 180. Sorry. It's 1440 degrees. So that's what a decagon's internal angles add to. Again, a 16agon, that's what we're going to call them, 16 gons, rather than what the actual wording is. I honestly don't know. So it's 16 minus 2 times 18, so it's 14 times 18. Sorry, not 18, 180. That's what I'm messing up. 180, clear. So that works out to be 2,520 degrees. A 30agon, so 30 minus 2 is 28 times 180 equals 5,040. Octagon is 8-sided, so it's 8 minus 2 times 180. So it's 106 times 180, which I think is 1080. Yes. 1,080 degrees there. This is actually 12agon, but I know it's actually a dodecagon. So that's 12 minus 2 times 180 equals 1,800. So a 12-sided figure has 1,800 degrees sums. The angles are summed too, and then the same thing, 35 minus 2 times 180, that's minus. So 33 times 180 is 5,940 degrees. Hope everybody's able to do that. Just remember, your equation is always n minus 2 times 180. Okay, so here on these next few that we worked on, work on these ones now. Again, answer the puzzles in a puzzle. Here I've given you the what one interior angle is. So this is just one interior angle. You need to figure out, so remember, this is going to be, so if we kind of just give you the first one, I'll write up the first one for you before I have you go off. It's the angle times n equals n minus 2 times 180. And you're going to work that equation backwards to solve for n. So work on those and then come back and check your answers. Okay, we kind of worked it through. So 150n equals 180n minus 360. I subtract 180n from both sides. So negative 30n equals 360. Negative 360 divided by negative 30 divided by negative 30. I end up with n equals 12. If you want to check it, kind of multiply that back through. And that should work out. Again, we have 160, so it's 160n equals 180 times n minus 2. Sorry if I keep messing up with writing it out. I'm going to try to do it now as 180 times n minus 2 because that's easier for me. So again, I got 160 n equals 180n minus 360 minus 180n minus 180n. The negative 20n equals negative 360. The math on that becomes n equals 18. 175, same thing. 175, I'm just going to do n equals 180 times n minus 2. Kind of see where we're going. I'm going to end up with negative 5n is going to equal 360, negative 360. When I divide by negative 5, divide by negative 5, I end up with n equals 72. So there you know, a 72-sided figure, the interior angles of a 72-sided figure are going to be 175 degrees. Again, with the 165-degree angle, we've kind of worked through, this is going to be negative 15n equals negative 360. Again, we'll divide that through. We have n equals 24. 144, 144n equals 180n minus 360. So when I subtract 180 from both sides, I'm going to be off with negative 56n equals negative 360. Not 56, 36. That should be 36. Bad math on my part. So n equals 10. Sorry about that. Subtracted there. Again, 135, subtracting that from a negative 180, I'm going to be left with negative 45n equal negative 360. That leaves me n equals 8. So now you know an octagon, the internal angles of every octagon is 135 degrees. Does that make sense to everyone? Has everybody seen that? Okay, so the last problem on this page is we're going to find the value of x given our diagram. So the first thing we're going to look is count how many sides we got. 1, 2, 3, 4, 5. So we have a 5-sided figure. So I have some crazy looking pentagon is what I have. So I know right away my equation is 5 minus 2 times 180 is going to equal the interior sum of all those angles. So if we do that math, we end up with 540 degrees. So every angle on the inside there is going to add up to 540 degrees. They've given me an equation for each angle on the inside of that equation. So now I just set all that equal to 540. So 540 equals, I'll start at the top, 4x plus 5 plus 5x minus 5 plus 6x plus 10 plus 4x plus 10 plus 7x. Look at my numbers, kind of add up all my x's. 4 plus 5 is 9, plus 6 is 15, plus 4 is 19, plus 6 is 26. So I have 26 x's. Then if I look at this quickly, I have a plus 5 and a minus 5 cancel, so plus 10 is plus 20. And that all equals 540 still. Trying to get x by itself, we subtract 20 from both sides. I'm left with 520 degrees equals 26x divided by 26. X equals 20. So there we know in our equations over here, x equals 20. Does that make sense? These are the type of problems you're going to see as we go forward on the homeworks and on the tests and stuff. So try to remember, count up how many sides, use your equation to find the sum of the interior angles, set all the angles on the equation equal to that number, solve for your variable. Done deal. Algebra and geometry, piece of cake. Okay. Exterior angles. Now we're talking about the exterior angle. So if we look at our diagram quickly, we have a 6-sided figure. So what I want to do quickly is try to figure out 6 minus 2 equals, or times 180, sorry, tells me how many they add to, which is 720 degrees. So my interior angles are 720 degrees. To find out what each angle is, so let's take a look at angle A here. If I want to know what angle A is, I just divide 720 by 6, and I'm left with 120 degrees, okay? If we kind of remember back to our geometry, this is a linear pair. So that means my angle here is going to be 60 degrees because that's what I need to add to 120 to get 180. So the exterior angles of all these, just to kind of look at it, they're all 60. So when I add up all those 60s, I have 6 of them. The exterior angles all equal 360 degrees. No matter how many sides the shape has, no matter what the angles on the interior look like, all the exterior angles of a convex polygon are going to add up to 360 degrees. There's no other math you need to do. Just know it's always 360. What that's going to tell you, though, questions you're going to see is find the sum of the measures, our example here. Find the sum of the measures of the exterior angles of a 27 gon. Shape has 27 sides. I'm not even going to draw it because I don't want to work that out. All you need to know is it's always 360. There's always 360 degrees. So if you got a question like that, find the sum of the measures of exterior angles, 360. You don't even care what side it is, how many sides, 360. What you need to work on, though, is when you do this. You want to find the measure of each irregular hexagon of the example I've used here, which is going to work out. You've already seen it. Now we're going to show you the math. We know the exterior angles add up to 360. How many do you have? Oh, I got 6 of them, so just divide 360 by 6. You're left with 60 degrees. Does that make sense? If we look back at our other example, the 27-agon, we're just going to divide 360 by 27. We find out if we were asked here, each angle measures 13.3 degrees. So whatever the sides of the shape has, just divide 360 by that number. That tells you what the outside angles all add up to. Make sense? Okay. Problems for you to work on. Again, the first ones, it's just pretty simple. Find the sum of the measures of the exterior angles of those three shapes. You should know what they are right now, not even have to think about it. The tricky part comes in the next 12, 9 there. Trying to figure out how many sides they are. We're just dividing 360 by whatever the number is. Just so you know, this is 7, this is 12. A heptagon has 7 sides. Dodecagon has 12 sides. I hope you know what an octagon is. So take a few minutes, figure all those out, plug the answers in the Edpuzzle, and come back. Okay, so all we're doing is 360 divided by whatever Rn is, so 12. These are 30. Hexagon is 6 sides, so 360 divided by 6, 60 degrees. 360 divided by 20, 18 degrees. 360 divided by 40 is 9 degrees. 360 divided by 7, a little trickier there. (51.43 degrees). 360 divided by 12, 30 degrees. 360 by 8, 45 degrees. Sorry, I just told you that's 12. We've already figured that. This is another 30. Sorry, that should be 30. That's a really bad 30. And 360 divided by 24. I believe that's 15. I'm just double checking on my calculator. This is 15. So that's all you're doing. Each exterior angle is just 360 divided by the number sides. Okay. Working in the parallelograms now. So parallelograms are quadrilaterals. They have 4 sides. What you need to know is both pairs of opposite sides are parallel. That's why it's a parallelogram. There are 4 other important properties you need to know. If a quadrilateral is a parallelogram, then the opposite sides are congruent. So opposite sides. So if I kind of draw my parallelogram in, and I tell you this is a parallelogram, then you know right away the opposite sides are congruent. Okay? Second, if it's a parallelogram, then the opposite angles are congruent. Angles are opposite, so these angles are congruent. These angles are congruent. Does that make sense? Also, if it's a parallelogram, then the consecutive angles are supplementary. Remember what consecutive angles are. Consecutive angles would be 1, then 2. Those are consecutive, so those are supplementary. And the last important thing you need to know, if it has 1 right angle, it's all right angles. Think of a rectangle. It's a parallelogram. My opposite sides are congruent. That's a 90-degree angle, so everything has to be 90-degree angle because the opposite angles are congruent. So if this is opposite to this, those are opposite. They're congruent. These 2 are supplementary, so that makes that 90. So that's why if 1 is right, they're all right. Sorry. So here we have our example. This is the type of problems you're going to get in this chapter. ABC is a parallelogram. Tells you it's a parallelogram. They want you to know. So parallelograms, opposite sides are congruent. We're trying to solve for A. 2A equals 34. I'm dividing by 2, so A equals 17. Done. Opposite angles are congruent. 8B equals 112. 8B equals 112. That's all we're doing. We're dividing by 8. I'm left with B equals 14. When you do that division, that's all we're doing. That's all this chapter is going to be. So we're de-emphasizing proof, so I don't have to prove that that's a parallelogram. We're just going right into it. It is. Do what you need to do with it. Again, your examples. It's 4 problems. We're just finding the variable, finding what x and y need to equal. Use the rules. Opposite sides are congruent. Opposite sides are congruent. Opposite angles are congruent. Plug your answers in that puzzle and connect. All right, so we're looking at, we got a square. We got one right angle. All the angles are right angles, so that makes 3x equal 90. So x here is 30. I have 4y equals 90. So here, y equals 22.5. Does that make sense? Okay. Here we get x and y. We're trying to figure out x is an angle, y is a side. So we're going to start with the side. 88 equals 8y. Opposite sides are congruent. Y equals 11. Again, another right angle, so 6x equals 90. X is going to be 15. Does this make sense? Okay. Parallelogram. You're told they're all parallelograms. This is a special type where my opposite sides are still congruent. This one specifically, they're all congruent. So I got 6x equals 12. And 3y is going to equal 12. So y equals 4. X equals 2. Make sense? We'll talk about that type of, we'll talk about this type of parallelogram later in the week. Okay. They don't tell me anything about this one. What am I going to do? I'm going to start with these two. I know consecutive angles are supplementary. So 6x plus 12x has to equal 180. So 18x equals 180. So x equals 10. Does that make sense? Does everybody see that? Okay. So now that tells me that this angle here is 120. So I have 3y is going to be congruent to 120 degrees. So it equals 120 degrees. When I divide by 3, y is 40. Make sense? Everybody see it? Awesome. Oh, here's another little tricky one. Kind of looking at this one. What are we going to do? How are they going to tell me? Again, we're going back to the consecutive angles are congruent. So I have 5x plus 55 plus 60 has to equal 180 degrees. So 5x plus 115 equals 180. Subtract 115 from both sides. And it was 5x equals 65. So x equals 13. But now I also know my 2y angle has to equal 65. So that makes y equal to 32.5. Everybody see that? Okay, again, opposite sides are congruent. Have an x, 30x equals 150, so x equals 5. So I plug 5 in here. So 72 times 5 is 360. So I got 2y equals 360. So y is going to equal 180. Has everybody seen that? Everybody seen how this makes sense? Opposite sides of parallelograms are congruent. Opposite angles of parallelograms are congruent. Okay. Now we need to talk about the diagonals of a parallelogram. We draw another parallelogram here quickly. The diagonals are the lines that connect the opposite angles. So if the quadrilateral is a parallelogram, then the diagonals will bisect each other. So that's going to tell me this equals this, that equals that. Important rule about parallelograms and their diagonals. It also tells me that each diagonal separates the parallelogram into two congruent triangles. So if I'm just looking at this diagonal here, I know that the top triangle is congruent to the bottom triangle. It'll help you with solving some problems later on. All right, here's our example. We got the two diagonals. We're trying to find x and y. The diagonals bisect each other, so this side is congruent to this side. This side is congruent to this side. So when we're solving them up, we just get 6x is going to equal 24. And then 4y is going to equal 18. Here, x equals 4. Here, y equals 2.5. Sorry, 4.5. My bad. 4.5 for y. Does everybody see that? Does that make sense? Again, this unit is all just a lot of algebra trying to figure out some shapes and stuff from some numbers from shapes. Again, know your rules. We're just working with the diagonals. The diagonals bisect each other. Trying to figure out what happens with the triangles. Number 3 is a special case. I'm just going to tell you with number 3 so you know. It'll help you out with solving for the variable, for the degrees. That's what happens with that one. I think everything else kind of shows you what you need to know with what you're trying to solve. Yes. Okay. Try those. Come back and check your answers after you enter them in Ed Puzzle. All right, so again, that's congruent to this. This is congruent to this. 4y equals 8, so y equals 2. 3x equals 12, so x equals 4. Same thing here. They're telling me that this is congruent to this, which then tells me that has to be congruent to that. So if one side is 28, my 4x side, x is going to be 7. Y is going to be 14. Make sense? Okay, again, the special type of triangle here. They bisect that, they're perpendicular bisectors actually, so that's a 90-degree angle in the middle. So if this is 90 degrees, that tells me this is 90 degrees, that's 60, so this angle here has to be 30, so x is going to be 15 degrees. Everybody see that? Again, now my other side is the same thing. Think of parallelogram. Parallel lines cut by transversal. We go back to that unit. We have parallel lines, draw them in red, cut by the transversal, alternate interior angles, that makes that angle 60. So 4y also equals 30. So your y here equals 7.5. That makes sense? Is that too fast? If you have questions on that one, again, we'll go over it with the rhombuses. That's what that's called, as a rhombus. We'll deal with it later. Here again, we have our triangle. We have our side. They've told me this side is 10. I have a right angle here, 30-degree angle, so that makes this angle 60. We just had a test on 30, 60, 90 triangles. My short side is x. I also know with the bisectors, this side here has to be 10. So 3x equals 10. So x is going to equal 10 over 3. We're just going to leave it as 10 over 3. You can do 3 1/3, but just leave it as 10 over 3. The other one, y, is my long side of my triangle. Do we remember what 30, 60, 90 triangles? What's the y? The y is the x square roots of 3 side. So here, y equals 10 square roots of 3. That's why we had to learn those special right triangles. We can just pop stuff in, and there we go. Does that make sense to everybody? Okay. Number 5, a little tricky. I know that side's 12. I'm not sure what this side here is. What I do know, though, is it's opposite my right angle. They're also telling me that these two angles here are congruent. So that tells me this triangle here, even though it's drawn kind of poorly, is a 3, 4, 5, a 44, This is a 45, 45, 90. So now I look, I have my short leg is 12, so that makes this side 12 square roots of 2. Remember those rules. So now I know 2y is 12 square roots of 2. So y is going to equal 6 times the square root of 2 because we just divided 12 by 2. Does that make sense? Again, 3x has to be 45 the way they're showing our equations there. So the x equals 15. Hope that wasn't too fast. Number 6 actually is the same picture, so that's my bad there. I gave you the same equation 2 in a row. Sorry about that. Okay, conditions for parallelograms. To tell us a quadrilateral is a parallelogram. Quadrilateral is a parallelogram, and it's each one of these is individual. It doesn't have to be all of them, just each one. So, a quadrilateral is a parallelogram if both pairs of opposite angles, opposite sides are parallel. The opposite sides are parallel, it's a parallelogram. Or the pairs of opposite sides are congruent. My opposite sides are congruent, again, parallelogram. Both pairs of opposite angles are congruent. Again, if that's true, you have a parallelogram. Same thing, the diagonals bisect each other. So if we kind of look at our picture and I drew in some lines so that those are congruent and these are congruent, you know they bisect each other, parallelogram. One pair of sides is congruent and parallel. So if I tell you that one side is congruent and that side's parallel, then you know you have a parallelogram. That's all. So either one of these, it doesn't have to be all of them. If one of them are true, if you can put a check mark next to one of them, then it's a parallelogram. So you got to kind of look at your picture and what are they telling you in the picture with their markings. So we're trying to find x and y in our picture to prove that this is a parallelogram. So they've given us the short side. Our short side is 2. Our long side here is 15. We're trying to solve for x and y to make them equal. So I just need to have two opposite sides being congruent and parallel. I don't know that they're going to be parallel, so I got to make sure that what I eventually want is that's going to have to be 2. This is going to have to be 15. So I think what we need to do, I got to set 6x plus 3 has to equal 15. I'm solving for x first, so that gives me 6x equals 12. So x equals 2. All right, so now I know x equals 2. Perfect. That makes that side 15. It makes this side 15. So now I'm going to have 4x minus 2y equals 2. I know x is 2, so 4 times 2 minus 2 times y has to equal 2. This should be 2, not 8. It's going to eventually be 8. So 8 minus 2y equals 2. I subtract 8 from both sides. I have negative 2y equals negative 6. Whoops, sorry. Negative 6. Base that to make that a 2. So it's neither. Divide by negative 2. Y is going to equal 3. Does that make sense? Now, because y is 2, y is 3, x is 2, that makes that shape a parallelogram. Okay. Again, you're finding x and y to prove that these are parallelograms, to make them parallelograms. Think of what the rules were. Opposite sides congruent. Both opposite sides. Opposite angles congruent. Both opposite angles. Diagonals bisect each other. Well, nothing where diagonals are bisecting each other, but just know what you need to know. My opposite angles have to be congruent, so piece together everything you need to know. All right, hopefully you get your answers in the Ed puzzle. My opposite sides have to be congruent, so 2x minus 2 has to equal 12, so 2x is going to equal 14, so x equals 7. 2y equals 8, so y equals 4. Parallelogram. Opposite angles are congruent, so x is 5. because 11x has to equal 55. That leaves my other angle here is 125 because of the supplementary rule. 155 plus 125 is 180. So 5y equals up to, has to equal 125, so there my y equals 25. Again, opposite angles are congruent. Here my y equals 5. This is the same question. It's different variables. Here my y equals 5. Same thing. 5x has to equal 125, so now x is 25. Different picture, same concept. Okay. Opposite sides congruent. Y is going to be 3. My opposite angles have to be congruent. I know that the way parallelograms work, these are alternate interior angles, the 45 and the 9x. So what we know about alternate interior angles is they're congruent. So for these two sides to be parallel here, x has to be 5, because my 9x has to equal 45. That makes sense. Okay. Same thing here. I have two sets of alternate interior angles. 2x equals 30, x plus y equals 24. Well, if 2x equals 30, that makes x 15. Now it's going to make my y 9. Because 15 plus 9 is 24. Here I know I got congruent angles. They tell me they're congruent. Consecutive angles have to add up to 180 degrees. Congruent angles that add up to 180 degrees are 90 degrees. So that tells me that everything's a right angle. I can write that in, that's a right angle. So they're all right angles. So here y is 15. Because 90 divided by 6 is 15. Here x is 30. Then all my angles are right angles. Does that make sense? Does everybody see that? Okay. That's the start of the quadrilaterals unit. Again, we're going to blow through this quickly. So if you have any questions, send me emails. I know there's some, I don't want you to get lost in all the stuff. You can definitely kind of follow along in your book too to make sure that